So sleepwalking, assume that 29.2% of people have sleepwalked. We want to assume that in a random sample of 1480 adults, 455 have sleepwalked. Now, assuming that the rate of 29.2% is correct, find the probability that 455 or more of the 1480 adults have sleepwalked. Alright, so what's going on here? So we have 29.2% of people have sleepwalked. So our population is people, and then we take a sample of 1,480 adults, and in that sample of 1480, 455 have sleepwalked. We want to know, right, if that 29.2% is correct, we want to find the probability that 455 or more of the 1480 have sleepwalked. And so this appears to be binomial because either they sleepwalk or they don't sleepwalk. So it fits the binomial distribution. So what is P? So we can say that P is the 29.2%, so 0.292, so that's P. So what about Q? Q is the failure. So Q, how do we find out? It will have to be 1 minus P. So in this case, 1 minus 0.292, which is by looking at our calculator, 0.708. So that's Q. So we have our P, which is the probability of successes, and Q, which is the probability of failures. So they should add up to 1. And then our N is the size of the sample, so 1,480. And so based on this, we can use the approximation to the binomial. So the mean is going to be NP. So 1480 times 0.292, which ends up being 432.16. And then NQ is going to be the 1480, again, the size of the sample, times Q, which is 0.708. And so when you do that on your calculator, you're going to get 1047.87. Now this, together, they should add up to the size of the sample. The size of the sample is 1480, so I think my approximation here is just slightly off, my rounding, but we are really close to the 1480. So that is our NP and our NQ, which notice they are both greater than 5. So that means that we can use the binomial, the normal approximation to the binomial. So this qualifies for the normal approximation. And so that means that the mean is going to be NP, which we already found it up there, is NP is 432.16, and the standard deviation is the square root of NPQ. N is 1480, P is the 0.292, right, or probability of success, and Q is the 1 minus P, so 0.708. And so when we put that into our calculator, what do we get? We get 17.49. So this is our mean, and that is our standard deviation. Alright, so that is assuming that the rate of 29.2% is correct, so that means the probability of success is 0.292. Q is 1 minus P, so the probability of failure is 0.708, and that's our size of the sample. So NP is greater than 5, and Q is greater than 5, technically greater than or equal to. And so this qualifies for the normal approximation, which the normal approximation tells us then, right, if these conditions are satisfied, the mean is n times p, and the standard deviation is the square root of npq. So that's what we just found. And so now we're ready to answer this question. Find the probability that 455 or more, so greater than 455, of the 1480 adults have sleepwalked. So we want the probability that x is greater than 455. So that's what we're looking for. So how do we find that? We need to convert that to z-score. So it essentially is the same thing as saying the probability that z is greater than something. And so we need to find that z-score. But remember, our z-tables give us the probability of z being less than. So that means we're gonna, well, let's find the z-score there, and then we'll talk about that. So our formula for z-score is that z is equal to x minus mu divided by the standard deviation. So in our case, our x is 455, so 455 minus the mean. We just found the mean right here in p to be 432.16 divided by the standard deviation. We found it to be 17.49, which gives us 22.54 in the numerator, and then we're still dividing by the standard deviation, and so now this is 1.2887. So rounding to 2 decimal places, because it's a z-score, we can say 1.29. So we want the probability that from up here, right, the probability that x is greater than 455 is the same thing as saying the probability that z is greater than 1.29. But when we look at our z-tables, the z-tables give us the probability to the left of the z-value, so less than. So that means that we want, this is the same thing as saying 1 minus the probability that z is less than 1.29. So if you're looking up the tables, this will be the z-score that you look up, 1.29, to get that probability, that area under the curve. So let's practice doing that, and then we'll do it with StatCrunch also. So going to our z-tables, we're looking for 1.29, so I'm going to go to 1.2, and 1.29 is the very last one, so 0.9015. So going back to our notes, that means this is going to be equal to 1 minus, what did we say, 0.9015 from the z-table, which when you do that in your calculator, we're going to get 0.0985. So that is the probability that we get 455 people or more that sleepwalk out of the 1,480 in our sample. So converting that to a percent, that gives us, what is that? Move the decimal place over 2, so about 9.85%. Now this is by using the tables, but we can also use StatCrunch to solve it. So if we go to StatCrunch, and remember for this, what is it that we do? We go to Stat, Calculators, and because we're using the normal approximation to a binomial instead of a binomial, this will be, we're going to go to Normal and Compute. And so we're going to put in our mean, the mean that we found, right? The n times p, which is 432.16. You're going to put in the standard deviation that we found, the square root of n times p times q, which we got it to be 17.49. And here our x is 455, but we want the probability to be 455 or more. So we notice that now it's shading, StatCrunch is shading that area, as opposed to the table gives us the area to the left. In StatCrunch, we can choose whether we want the area to the left or whether we want the area to the right. So 0.0957, which is, oh, we're slightly off. So if you wanted to copy your StatCrunch result, go to Options, Copy, and it gives you a new image to copy. So we're going to right click on this, copy image, and then we can go back to our notes and paste it in here. So here's our image. So rounding to 2 decimal, or converting it to a percent, this will be 9.58%, and this is 9.85. So StatCrunch is definitely more accurate. So I have a feeling that there's an algebra error here. So these answers should be the same, and I think I just noticed what it is. 455 minus 432, that is not 0.54. So this, I have a little algebra mistake there. That should be 22.84. So I misread my 8 as a 5. Divided by 17.49, that should give us a different number here. So we get 1.305. So rounding to 2 decimal places, 1.31. We round to 2 decimal places so that we can find them in our table. So this should be 1.31, and so this is going to be now more accurate. So when we go to our z-score, we're looking for 1.31, 0.9049. So going back to our notes, this should be 0.9049. And so when we do 1 minus that, what do we get? So 1 minus, it gives us 0.0951. So rounding or converting it to a percent is 9.51%. So now let's compare. So that makes more sense. So 957. So we're still a little off, but not by the amount that we were. So I knew there was something wrong, so it was better to check my math here. And as you can see, StatCrunch is definitely more accurate. And but I wanted to not re-record that, but actually leave the mistake there just so you see how easy it is to make a mistake, and also how you can double check your answer using StatCrunch. And so this gives us the probability that x is greater than 455, so that gives us essentially the probability that 455 or more of the 1480 adults have sleepwalked. Now we can say is about 9.51%. So part B is that result of 455 or more significantly high? No, right? Our z-score was, what was it, 1.31, which is not more than 2. Part C, what does the result suggest about the rate of 29.2%? Well, since our z-score is not significantly high, then we can say that the result of 455 does not provide strong evidence against the rate of 29.2%. So the rate could very well be 29.2%. This z-score doesn't say anything against it, right? Had this been like 2.5 or 3 something significantly high, we could have said like, wait a minute, maybe that rate is not quite accurate. But because this isn't significantly high, we can say that this rate could very well be possible. So I hope that that makes sense. So essentially, because the z-score is, the 455 gives a z-score that is not too far away from the mean, that then assuming that the rate is 29.2% the probability of success, then this z-score is not saying that we have a significantly high value. So the 29.2% could be accurate for the probability of successes, right? So if the z-score had been really high, then we would say that result is unusually likely. So we tend to kind of reject that this is the accurate rate. But in this case, we're right along with this rate, so it's not too terribly far apart. So we don't have strong evidence to suggest that the rate of 29.2% is not accurate. All right. So hopefully this kind of helped to see how we can approximate a binomial distribution with a normal distribution. And this is because we can do it by hand. You could still use the binomial probability formulas that we discussed in the previous chapter to find this probability, but this allows us to be just more consistent. If we're able to use the normal distribution, it gives us a better idea because we have the bell-shaped curve. All right, email me if you have any questions.